Rightio, kia ora koutou. So I've made this little video about bearings. Like all videos, it means you can pause it, you can rewind it, all of that stuff if you suddenly stop paying attention. This is related to our maths book, our geometry book, and I am currently on page 47. Okay, I took photos of these 2 pages. Their explanation is really beautiful and straightforward. But I'm gonna talk to the book effectively. That doesn't mean I'm talking to the book like, hi book. That's a saying. I'm talking to the stuff that's in the book. So 47 and 48, I took photos of the pages and they're not very clear at all because it's evening and I'm sussing up my new computer and the camera. I can't take photos as easily as I could on my old one, but that's okay. So I'm sorry that the photos aren't very good, but I know that pretty much all of you have got the book. So page 47 is where you want to go. All right, so bearings. As I think all of you probably will know, they are what we use for navigation. So, your pilots and your yachties and your running enthusiasts, anyone who's into maps, your geographers, they all love bearings. There are compass directions, and that's, your north. Oh, sorry. I'm just realizing the camera, but which way it goes, I'm not sure, but it's you never eat salty water and it goes clockwise. Okay. I'm not sure which way around you'll be looking at this. So I'm thinking if I go like that, it might be back to front. So it always goes clockwise. Okay. Same way that your clock goes. So, north, east, south, west, and back up to north. Bearings are where we give values for basically how many degrees around that whole circle we're going to go to head in our direction. Okay, those degrees start at north, so we always start our bearings facing north. On a map, that's always pointing straight up. So we always start here, pointing straight up. It's a vertical line, and that's at 0, 0, 0 degrees. We use 3 digits for bearings, okay? So it's not just 0 degrees, it's 0, 0, 0 degrees, okay? That's a nice way too for people to know, because being used in navigation and things, you need to know that you're being accurate and that you haven't just misheard a number. If you've heard 3 digits, then you've heard it right. Whereas it would suck if you said 2 digits and say off you went at 26 degrees, but actually it was meant to be 260. Okay, all right, so it could also be 360 degrees. Okay, so due north can be written as either of those. Okay, then as we go around, as we've got northeast, that would be at 45 degrees, so 045. Then we've got 90 for east, etc., and they're all in your book there. Okay, so when we read a bearing, we have that north, that line that's pointing north, and we just read round to wherever it's going. So for example, if I'm standing here and here's my map pointing north, and I want to visit a little house that is over here, my bearing that I'm going to take from where I'm standing, okay, so here's the point here where I'm standing, my bearing, I'd draw a line that goes up for north, and then I would draw a line from where I'm standing to the house, and then I measure this angle there. Okay, so how big that angle is, I'm going around clockwise. So in this case, it'll probably be, I don't know, maybe about 78 degrees, let's say. Okay, because it's a bearing, it's not just 78 degrees, 078 degrees. And that's the way we do them. If you're wanting to head to, if in fact I was actually wanting to go and visit my mate who likes to hang out here by a tree, then I need purple again, and here's the point here. Then again, I'm going to do my line that points due north. Use orange, points due north, and I go all the way around to the line here that I'm going to walk along. So my bearing will end up being at least 180 degrees, probably around 200. Okay, so that would be the bearing that I would take to visit this wee friend here. So the bearing from me to my friend would be 200. All right, so we've got an example here where they have got a cross-country run, and the first stage, which is AB, this line here, AB, is 400 meters. and we're told that it's on a bearing of 142 degrees. The second stage, BC, is 500 meters on a bearing of 052 degrees. Okay, so there's a few things that we want to do. So the first one is calculate the size of angle ABC. Okay, so let's first of all just check on what we know from what they told us in the original explanation. So they told us that the bearing is 142 for AB. Okay, so let's put that in. So from north, we've got to have that line pointing north, and it was 142. So all the way around to that line AB is 142. Sweet. That second stage, BC, was on a bearing of 052. So we've got 52 degrees. So there's our line pointing north. So that means this angle in here is going to be 52 degrees to that line, BC. Sweet. Okay, so put that information in there that you know. Make sure you're being careful. Always starts from that line of north and going around clockwise. So to calculate the size of the angle ABC, we're actually going to need a little bit more info, aren't we? Because we need to know how big this angle here is. And we're going to need to add that to 52 degrees. So how on earth could we work out how big that angle is? Have a good look at this. So the lovely thing about bearings and the fact that we always go from each point, we do our bearing from north, is that we end up with parallel lines, eh? So for all our different points all over the map, we end up with a whole bunch of parallel lines. So that's what we can use, is some of those parallel line angle properties. And of course, we've got heaps of them up our sleeves. So when we talk about parallel line angle properties, remember that we're talking about a line that traverses both of those parallel lines. I couldn't use a parallel line rule if we're then talking about a different line and it doesn't actually go through the two of them. So just do watch for that. So let's have a look. We've got two parallel lines here, don't we? Both from A and B. We've got those two lines pointing up to north. They are parallel lines. So X, of course, is co-interior. Okay, and that's why you'll see in here we've got 38 degrees. Okay, co-interior angles add to 180. And then we're going to add that to the 52. Okay, so what we end up with is 90 degrees for angle ABC. All right, part B says calculate the length of the third angle of the third stage. This is very difficult to read, so I'll go back to the book. Here's the third stage there, which is the line CA, or from C to A. They mentioned that it forms a right angle triangle. We already knew that because that angle ABC was 90 degrees, wasn't it? So we've got a right angle triangle here. Nice. So we want to find that length of the third stage. We've got a right angle triangle. If you ever need to, when you're doing any geometric reasoning problems, if you want to redraw the diagram for just the parts that you want, then do that. Okay, it's a really helpful thing to do. And so in this case, let's say that we do that. We've got A, B, C. We know this is 90 degrees. So instead of that messy stuff with the north and all of that, let's just put in that right angle there. We know this is 500. We know this is 400. Straight away, you can see that we can use Pythagoras, can't we? So we end up with AC squared being 500 squared plus 400 squared. What do we end up with? 680.1. Okay, once you've done the square root of that. Okay, nice. So that we've used parallel line rules and we've used Pythagoras for this, for bearing. So it's a really lovely way for a few of our rules to all come together. Let's have a look at the next. There's another question there's another two questions, related to our orienteering course. So now we want to calculate the angle CAB. Okay, CAB, the A is in the middle, so we want to know what this angle here is. You now know more about this. You know that this is 680.1 meters. You want to work out an angle. So now we're thinking trigonometry. Okay, sine, cos, or tan. You've got all three sides, so you could decide what one you want to use. In the book, they use tan because they're going to use the 500 and the 400. They're nice round numbers, but totally up to you. Okay, so that's just a nice normal tan question of finding the angle. Part D, calculate the bearing of the final stage of the course, which is CA. Okay, so that final stage, we've worked out how far it is that they've got to go, but now we want the bearing. So that means we're going to need to be pointing up from C, and we want to go, okay, because we went from A to B to C and back to A, so we're going from C to A. So we want to know how far is it all the way around there. Okay, well, what are your thoughts? Let's go back to our original picture. All the bits and pieces that we know. We've got degrees going on here, don't we? We've got different angles going on. We know that that bit around there is 142. Let's do our due north there. It's this here that we are wanting to find out. All right. So having a wee look at this, there's parallel lines going on here. We've got our we've got this, I'll do it in a different colour, we've got this line here going on between our due north from B and our due north from C. You can see that line there that's going between those two parallel lines. So we could, if we extend that out, that means this bit here would also be 52 degrees, wouldn't it? Sorry, I'm using my rainbow pen now. So that's one thing that we could use, corresponding angles on parallel lines. Then we know that we've got 180 for this whole big bit there. And then we're just left with this little bit here on the inside. That little bit there on the inside we can work out because we now know that 90 degrees down here, that this is 90. And we also know this top corner one because you've worked that out for the last question and ended up being 54 degrees. So now you could do 180 minus 90 minus, what was it again, 54 degrees. And that's going to tell you what this wee guy in here is, okay? That wee guy in there, what does it end up in? So what are we, 90 minus 54? So we've got 36, okay? So we end up with 36 for that tiny bit. We've got 180 for that bit there and 52 for that bit up the top, okay? And you can see it written in the book, written out a little bit neater. Just make sure you put your little reasons like they have there as well beside each step that you do. All right, let's look at example 2 very quickly because it's a juicy one. So sorry, that working should go down there. Example 2, we've got Hannah and Brent. So there is an error, by the way, guys, at part C here. A very minor one, but it is an error nonetheless. So they've both gone for a walk. They've both walked 150 metres. Okay, Hannah walked on a bearing of 208. So Hannah, starting here from A, went all the way around there. 208 is larger than 180, so we know she's the one that's gone the furthest over there. So Hannah ends up over here on the left. Brent has gone on a bearing of 102 degrees. Okay, 102. So the first question is calculate the size of angle BAC. So we've got B down here, A here, and C. Size of BAC and use it to find the size of angle ABC. They do this a bit of a funny way, actually, I thought. As quite a few of you can probably will have done, as you will have gone, oh, well, if she's done 208 all the way around there, and he's done, we'll do this one in orange, 102, and that's 102, then we could do 208 minus 102, and that'll tell us what BAC is, won't it? That's 106. They do it in a slightly, sort of two-step way. Either way is fine, but to me it seemed a lot quicker to just do one minus the other. Okay, so therefore, angle ABC, where are we at? So angle ABC, so we're wanting this wee guy in here. Okay, we know now that this guy here is 106 degrees. We have been told that Brent and Hannah both travel for 150 metres. So, in other words, those sides are equal. It's an isosceles triangle. So we're going to be thinking of properties of isosceles triangles for this question. So we know that angle ABC is actually exactly the same as angle ACB. Okay, that's why they can then do 180 minus 106, because angles in a triangle add up to 180, minus the 106, and then just divide it by 2, because they've both got to be the same. That's the base angles in an isosceles triangle. Calculating the distance between Hannah and Brent.